Okay, here there are two figures of blast furnace, which I would like you to pay attention on it on them, because what we would be discussing now, you may need some idea of the various zones of the blast furnace. So, especially like this is the Bose region, and sorry, this is a Bailey region, which is sort of a cylindrical, and this is a Bose region. So, like here you can see this is a Bailey region and this is a Bose region, and this is the stack region, dead main zone, and this is the hearth combustion, Bustle pipe. So, that is Bustle main, and Bose angle, tuyers, below pipe, gooseneck, mantle, tap hole, bell, throat, stock line. These are the things which we would be discussing in this one, especially about the Bustle pipe, blow pipe, mantle, Bose belly, stack, and this cooling plates where water cooling is taking place. So, you should be aware of the position of these zones and other thing, and this is a bell-less charging and with the bell. So, you should be aware about the difference in this, though we have talked already about this in the construction and interior of the blast furnace and all those things. So, just to refresh your memory, I am again showing this figure to you, so you can understand when we go further about the blast furnace few operations. So, there are two important operations in the blast furnace. One is blow in and another is blow out processes of a blast furnace. So, a process to start a new or relined blast furnace is called as blow in. So, either it can be a new furnace or it could be even a relined one. So, the main steps in this process are, so how to start the new furnace. The steps are drying, filling, lighting, and finally the operation. So, we will discuss these 4 steps one by one. So, you can understand what is the meaning of all these and how long it takes and time. So, the first step is drying. So, a newly lined furnace contains significant amount of moisture, which must be removed before the furnace is put in the normal operation. So, this is a very critical step and very important, and one has to make sure all moisture must be driven away, and the time spent in this is worth it than later on regretting when some problem comes or you encounter during the operation of the blast furnace. So, it is a worth spending time on removing of the moisture completely from the bricks and other places. So, and this can be achieved by adopting one of the following method. So, either to supply hot blast into the furnace from the stove. So, if there are existing blast furnaces in the plant, you can always use the stove of that one to supply the hot blast. So, initial blast temperature is around 200 degrees Celsius, and which is slowly raised to 400 degrees Celsius, keeping the blast volume low. So, that can be done from the tap holes and through the tubes. You blow that hot blast, which you get it from the stove. If the stoves are not there and there is only standalone blast furnace in the plant, then one can use the second method, hearth fire method, what is known as. So, in this method fire is built in the hearth using wood, coal or coke and controlled through the tier shutters and furnace bleeders. It is difficult to regulate the temperature in this method. So, in this one at the bottom of the hearth you use this carbonaceous material to burn it by using the control air through the tiers, shutters and furnace bleeders. But only problem is in this one it is a bit difficult to control the temperature in the furnace. But if stoves are not there, this is one of the method one can adopt to remove the moisture and heat up the furnace in the starting. If that is not there, then there is another method which sometimes is used, though it is bit expensive. So, in this one you what is called the Dutch oven method. So, in this one usually 2 or 3 ovens or 4 ovens are built outside the furnace. So, this is actually in one way the extra ovens you are building outside the furnace. So, more sort of infrastructure and money is needed in this one. So, it is a bit expensive in that way. So, ovens are built outside the furnace and the product of combustion with excess hot air are directed to tap holes and some to the tier opening. So, essentially what you are getting a hot product of combustion from this, and with the excess hot air which is directed from tiers or tap holes opening, you get the temperature the way you get it in the first method. So, by adopting this one of these method, one can remove the moisture from a new blast furnace or relined furnace, which is an essential step toward the operation. So, second step comes is the filling. So, after drying and clearing of the furnace, if you have used the second method or some other, so you have to remove whatever is left over there. And clearing of the furnace, its temperature is brought down by turning on the coolers, and inspection is carried out of all the material, mechanical, electrical and physical equipment before filling the furnace. So, this is a very important and essential part in all the blast furnace starting up, because now this is the last chance which gives you to rectify if there is any problem in any of the equipment. Coolers are on, so temperature goes down in that one, even the personnel can go inside and check the things and check all the thing outside, cooler, mechanical, electrical, physical, all things are running, and one can check if there is any problem, because when the furnace is operation, all these things are quite expensive and very difficult to maintain. So, this to-do list is prepared during this time, and all checking takes place in during this time before filling. So, usually startup charge consists of coke and a small amount of flux below the mantle. So, below the mantle you put coke and a small amount of flux. Sometimes wooden sleepers are used near the tap holes to facilitate the gases to escape. So, when the temperature start rising, so due to this coke, flux and things are there, then sometimes it's difficult really to escape the gases. Of course, they go from the top, that time top is also open in the starting, but you can put the wooden sleeper near the tap holes. So, that gives a good sort of passage to escape the initial gases. Flux is added as mentioned here, so that it can combine with the coke ash to form slag. Often limestone and slag is charged in the Bose region. So, the early high volume slag in the hearth makes sure that hearth is heated up sufficiently to receive the liquid iron. So, naturally you are putting a small amount of flux. So, starting slag is more towards siliceous side, silicon side, and that is actually good, and you need also high volume slag. So, you put more slag and that make the hearth heated up. So, it is able to collect the liquid iron when furnace is in the normal operation. So, on the coke blank above the mantle level, low ratio of iron ore to coke, generally 0.5 to 0.6 is placed, and this ratio is increased gradually. Naturally, the first few casts will have a higher silicon content, which may go up to 4.5%, which is brought down to normal levels slowly when the blast furnace moves toward the normal operation. When we say towards the normal operation, slowly as you start this iron ore to coke ratio to the normal one, and then the normal operation is established, your even silicon content also reduced during that time. So, this is the filling process after drying is done in the blast furnace, and after that once you have packed it with ore and other things, then lighting. So, lighting and operation, it has been combined into one. During the starting we put it third and fourth, but here it is combined, but it does not matter, you can see the difference. So, usually the hot blast air in the temperature range of 550 to 650 degrees Celsius is introduced through the tuya, which ignites the coke within a few minutes. So, when you are injecting that sort of high temperature blast air, naturally coke will ignite very soon. So, in other method, so this is one of the methods. In another method, what we do, we put easily combustible material are placed in front of the tuya, and that are ignited using the gas torches or red hot bar by inserting the red hot bars. These are sort of a old one, mostly using the gas torches to do it. Burning is allowed with natural draught. So, before ignition, the wells, that is top wells, are opened and dust catcher dump valve is closed. In the starting lots of gas amount, dust and other things would be there. So, tap holes are kept open so that hot gases can escape until the slag begins to appear. So, these things are done till the slag begins to appear in the hot region. So, when a good amount of gases emerge out of the top, the valve are closed and dust catcher dump valve is opened. So, now all the gas and dust catcher goes through that. Within 24 to 36 hours after startup of the furnace, the first metal is cast, which is very high in silicon content. Slowly ratio of iron ore to coke in burden is increased until normal operation is established. Sometime charge calculation is made based on top gas analysis, especially CO/CO2 ratio. So, as we mentioned in the previous in this slide that ratio of iron ore to coke is 0.5 to 0.6 and slowly you increase it in 0.05 or 0.3 sort of ratio slowly. And another way of doing it, to analyze the CO/CO2 ratio, and based on that you can slowly increase the iron ore content into the charge. So, that is another way of doing it until the normal operation resumes. So, this is sort of a normal starting process of the blast furnace, which is a new one and relined ones. Many times you shut down the blast furnace when its life is over, and you have to reline it, and again you have to start in the same way. So, some of the this figure shows a typical blow-in cycle of a furnace. So, this is showing hours. This shows the silicon content in percentage, and that is the hot metal temperature. So, as you can see that when it starts, so it is not taking care of the time of drying and other. So, when the blow filling and after lighting start, the third step, and slowly the temperature rises, and so here you do it, and first metal sort of probably is appearing somewhere here, and you can see the slag had already built up, and slag content slowly increasing, the actually silicon content in the slag, and which you can see silicon content in the slag is reaching almost 5%, and it is slowly reducing as you start. So, there you can say probably the first casting of the slag, which is appearing here, and because you are starting the now ore to coke ratio in increased form, slowly this ratio is coming down, and it finally it reaches to its normal silicon content less than 1%. So, that is where the normal operation is resumed, and even your hot metal temperature is getting stabilized here. So, this shows almost 3 to 4 days minimum is taking to get the normal operation of the blast furnace after blowing. And so, like blowing, we also have the operation like blow down or blow out. So, blow down and blow out is after reaching the campaign life, the furnace is shut down for relining. The process of shutting down the furnace is known as blow down or blow out. However, between blow in and blow down, the furnace may at times have to be shut down for short period for various reasons like serious breakdowns, raw material shortage, labor trouble, etc. So, one is furnace has reached the campaign life, so it has to be completely shut down, empty it for relining, or by other reason if one has to shut it down completely. Another one which is very often it is done in the plant due to very serious breakdown in the equipment or in some other thing. Sometimes you are running sort of raw material shortage, labor problem or any other thing comes. So, you have to shut it down, and not in a sort of a shut it down is in one way you have to hang the blast furnace for few hours to few days depending what sort of problem it is. So, you can't really shut it down the blast furnace due to this problem, because as you know it is quite difficult shutting down the process. We will discuss about that, and not just shutting down, especially the restarting of the blast furnace, that the blow in. It is a long process and quite expensive one. So, one cannot just shut it down like that. So, there are ways when a short period disruption from hours to days happen, there are ways by which this sort of problem can be handled. So, there are some methods. So, various types of shutdown are described below. One is fanning. So, when the full production capacity of the furnace is not required for time being, the hot blast rate is reduced to 20 to 25%. Many times it happens there is a less demand and supply is more, so you have to reduce the production, and one of the reason that time you can do by reducing the hot blast rate to this, or some thing at the downstream has broken down and then one has to take care of it. So, one has to again reduce the capacity or production rate of the blast furnace. So, that is the time you take the hot blast rate by 20 to 25% out. So, this method is known as fanning. So, in this method furnace can be resumed to normal operation at a relatively short notice. It is used for emergency and short period only. Prolonged use of it may result in hearth buildup and wall scale formation. So, this is for a very short period, it is used for emergency and other thing. So, this is one of the ways you can reduce the or blow down the furnace for few hours. Another one is back drafting. So, back drafting, when the blast is taken off for the short period of time. So, here you are taking off the whole blast, nothing is coming. In the previous one you can see 20 to 25% is reduced. So, here when the blast is taken off for the short period of time to perform various maintenance operations, the process is known as back drafting. So, as soon as blast is stopped, the wastel pipe is put under slight negative pressure. This is done by opening chimney valve and hot blast valve to a stove where air is admitted through the peep sides and stove burners to burn the gas in the stove. Bleeders at the top of the furnace is also opened to pull some of the blast furnace gas out. In some blast furnace, a special backdraft stack is installed for this purpose, avoiding the use of stops. So, many terms which are used here, excuse me, you have seen in those figures. So, I do not have to repeat, otherwise you can go again look at the figures and see those things. So, so in this one actually a negative pressure is put on the bustle pipe and stops, the gas is burned in the stove. Bleeders at the top of the furnace is also open and to pull some of the blast furnace gas out, and in some blast furnace a special backdraft stack is installed for this purpose. So, if this is there, then you do not send it to stoves and you avoid the use of stoves in that. So, that is called backdrafting. And another process of blow down is banking. So, it is a standard procedure for blast furnace to shut it down on temporary basis. So, example for again scheduled repair, breakdown, etc. So, this is actually for a longer period of time in comparison to your this backdrafting. So, in this process blast is taken off covering the fire with coke. So, it is totally taken off covering the fire that is at the top with coke, lifting up all air inlets and smoothing the stock with fine materials. Thus, the heat is preserved in the hearth so that furnace can be put in normal operation with minimum efforts. So, you are covering your fire or actually the stock with the coke, just closing up all air inlets and smoothing the stock with fine material. So, you are preserving the heat. For longer time shutdown, banking burden is similar to the blow in burden. If you would like to shut it down for a much longer period, then the burden would be the same as we had in the blow in period. So, when the coke blank reaches the top of the boss, the blast is taken off, all the metals and slag accumulated in the hearth is tapped, stock is covered with fine ores to prevent draught, the tap holes and tears are plugged in, bleeders are opened, steam is turned into dust catcher, the blast furnace is isolated from the common gas system and bells are closed. So, these are the things which is done, and this one in fact it is necessary that every day one should inspect it, the level of the stock, how the charge is sinking. So, daily inspection of stock level is necessary to take the proper measure. The furnace is restarted by replacing the tear and notches and charging sufficient coke to fill up the space created by sinking of the stock. So, all other steps are similar to blow in operation. So, this is actually for a longer period of time. If you would like to shut it down the furnace, then banking is done. And in this one every day one has to inspect the stock and take the necessary action. It should not be descending very fast, the necessary action should be taken. So, sufficient so most of the other steps in this one are like a blow in operation which we had discussed before.